In November 2017, an incident occurred at an aircraft hangar while avionics aircraft maintenance engineers, referred to as maintenance engineers in this video, were installing specialised avionics equipment in the nose section of a helicopter. At approximately 2 p.m, a maintenance engineer informed the chief engineer that the emergency flotation system nitrogen cylinder would have to be removed from the helicopter in order to gain access to the intended work area. The chief engineer tasked a maintenance engineer to remove the nitrogen cylinder. With assistance, he began preparing to remove the nitrogen cylinder from the nose of the aircraft. While carrying out the task, they noticed there was a placard stating that the cylinder must be discharged prior to removal. After some discussion, they sought guidance from the chief engineer on the appropriate course of action. The chief engineer agreed that the cylinder should be manually discharged prior to removal, but did not provide any specific guidance on the method of discharge or where instructions could be found. Returning to the task, they were still undecided on the method of discharge. At this time, another maintenance engineer joined the pair, and he too indicated his reluctance to manually discharge the cylinder. Despite this hesitation, the three workers donned hearing protection as they prepared to manually discharge the cylinder. At approximately 3:55 p.m, they initiated an uncontrolled release of the contents of the cylinder, which was pressurised to approximately 3,500 psi. The force created by the sudden release of nitrogen bent and dislodged a pipe which impacted one worker at high speed, throwing him approximately 2 metres, where he struck one of the engineers. The engineer suffered serious injuries to his abdomen, groin area and upper legs. Immediate medical attention was provided and emergency services were called. A safety-wise investigator undertook an investigation of the incident utilising the Incident Cause Analysis method, ICAM, to determine the basic cause of this incident and, importantly, identify all contributing factors. The investigation found that the basic cause of this incident was that the work team used an undocumented work method to discharge the cylinder. However, importantly, the investigation also identified multiple contributing factors which were classified as per the ICAM analysis. Some of the absent or failed defences identified, which are those contributing factors which normally prevent this type of incident or limit the consequences, included the poor placement of a warning placard which was not clearly visible to the work team, and the original equipment manufacturer, OEM, instructions were not available to the work team. Individual or team actions, those actions that led directly to the incident, included the fact that the work team used an undocumented work method, the hazards of working with a high-pressure cylinder were not identified or assessed, and the chief engineer did not provide clear instructions or provide adequate supervisory control over a high-risk activity. Task or environmental conditions, the workplace and/or human factors in existence immediately prior to or at the time of the incident that directly influenced human and equipment performance, identified there was a high workload and a tight time schedule at the time of the incident. These conditions appeared or were allowed to go unchecked due to deficiencies in organisational factors, such as the fact that there was no safe operating procedure for discharging the nitrogen cylinder and the company had no active system of hazard identification or risk management. As per the ICAM process, the following actions were recommended based on the hierarchy of controls in order to achieve our goal of prevention of recurrence and reduction of risk. Standard Operating Procedure. Develop a risk-based standard operating procedure, SOP, for the installation and removal of high-pressure cylinders. Risk Management System. Develop adequate control measures to ensure that risks are reduced to a level that is as low as reasonably practicable. Maintenance Organisation. Conduct a review of the organisational structure, roles and responsibilities to improve the quality of supervision and the management of hangar risks. Time Out for Safety Program. develop and roll out a program to empower staff and contractors to call a timeout if they consider the work being undertaken is unsafe or too high a risk. Our final step in the ICAM process is to identify key learnings that could be applied more broadly across the organisation or industry. The key learnings from this investigation are incompatible goals, the presence of conflicts between production, planning, safety and economic goals can often lead to risk-taking behaviours. Production pressure. If people are put under pressures and time constraints, they are likely to ignore or circumvent the rules to achieve unrealistic goals. The key learnings from this incident can be applied to all industries working with high-pressure equipment. While it is fortunate that no fatal injuries were sustained during this incident, it is imperative that the safety of all personnel should be considered the highest priority in every organisation, beyond production and economic goals.